Hey everyone, it's Mrs. Brimlow, and today we're going to learn how you graph systems of equations. So there is a copy of the notes linked in Canvas. You can also get a copy when you return and watch the video, whatever is easiest for you. This is actually going to be a foldable, so although if you print it out at home, it won't look that way, but we're going to focus on this part right here with the writing. I am going to fold it over for myself. Like I said, copies are available in class. Or you can just copy down the notes part. It doesn't really matter. Okay, so when graphing systems of equations or solving them in general, there are three types of solutions we can run into. One solution, no solution, or infinite solutions. So we're going to take a look at those today in all forms through graphing. Starting with one solution. So there are multiple ways you can tell how many solutions a system has just by looking either at their equations or their graph. So I like to always start with the equations just to get an idea of what my graph should look like or use it as a way to check my work. So when we're looking at systems with one solution, you're going to notice that the slopes are different. The y-intercepts may or may not be the same. Y-intercepts don't matter, it's the slopes that matter, okay? When graphed, the two lines intersect at one point. So they will have one solution in common, okay? And once again, there is one point where they intersect, so there is one solution, okay? So we're going to graph this example here. So notice it's in slope-intercept form. And like we talked about, their slopes are different. So right away, that's how I know they're going to intersect at a point and have one solution. So I'm going to use some markers for this just so we can see the different colors. So my first line I'm going to graph in purple. So my y-intercept is -3. Okay, so that means that's where it's going to hit the y-axis. So starting at the origin, I'm going to go down 1, 2, 3, and I come back up here to see the slope is -2 or -2/1. Because it's negative from my y-intercept, I'm going down, and then I'm going to go to the right one. So down 2/1. Now, this is the only point I can get in this direction, but we can also work in the opposite direction to get a few more points. When working with systems, I like to have more points, so hopefully I'll see where they intersect other than just drawing the lines. So if you need to get points in the opposite direction, you do the opposite of what your slope is. You basically will flip the signs. So instead of going down, I'm going to go up. And instead of going to the right, I'm going to go left. So you can see how this line is continuing. So we're doing the opposite. We're basically moving that negative sign from going down to making it go left. So up 2, left 1, up 2, left 1. Okay. And before I draw my line through it, I'm going to draw my second graph. So y equals 2x plus 1. So I'm starting at at 1. Okay. And then the slope of 2 tells me I'm going up 2/1. Now, I already know that the point of intersection can't be in this direction because that's not the direction the other graph is going. So I'm going to stop and do the opposite. So instead of going up, I'm going to go down. And instead of going to the right, I'm going to go left. And here's that point of intersection right here. Okay. Now I'm going to draw my lines through this as best I can. Just give me 1 second to grab a ruler. All right. So when we are drawing lines on a graph, we try to go through the points as best we can, extend our lines a little bit. That way we can show that this line continues. And then we do the same for the other line. And you can see where they cross and meet at this point right here, -1, -1. So my solution, -1, -1. What that means is that point is on both of these graphs. They share that in common. So that is the solution. And if I was to substitute that into each equation, it would show that it's a true statement, that it is a solution, that it is part of each function. Okay. So one solution, they'll intersect at one point. Okay. So the next one we're going to talk about is no solution. So before you even start graphing, you're going to notice that the slopes are the same. And you're going to notice that the y-intercepts are different, which means they're moving at the same rate, they're moving at that same pace, but because they're starting at different spots on the y-axis or hitting at different spots on the y-axis, they're never going to meet. They're going to look like railroad tracks. They're going to be parallel to each other. So when graphed, the two lines are parallel. So there is no point where they intersect, so there is no solution. There's no point of intersection. There's no point that they share or points that they share in common. Okay. So once again, I'm going to use two different colors to graph these lines so we can clearly see. And once again, I want to point out that their slopes are the same. So they both have a slope of 2, so they're moving at that same rate, but they're not hitting at the same place on the y-axis. So starting with that first one, I'm going to go from the origin down to -3. This has a slope of 2 over 1. So I'm going up 2 over 1, up 2 over 1, up 2 over 1. I like to have a few points, at least 3 if possible. You really only need 2, but the more points you have, the more accurate your line is. I'm not drawing, you could get some more points in the opposite direction, but because I know they're not going to intersect, it's not really necessary. I'm not looking for a specific point of intersection. So for my second equation, I'm going to start at 1 on the y-axis. So from the origin, I go up 1 and same slope. So up 2 over 1, up 2 over 1. So you can already see how they're parallel because they're moving at that same rate, but they're hitting the y-axis at two different places. So I'm going to go ahead and draw lines through my ordered pairs, and then I will show you what it looks like. Now, if your lines aren't perfectly straight, it might not look like it's going to be parallel, which is why it's always good to go back and check your equations to see same slope, different y-intercept. Okay, so this is no solution. Last but not least, we have infinite solutions, which means the lines end up being exactly the same. They share all the same points. I'm just going to move my face over and you can see this well. All right, so what you'll see is that the slopes are the same and the y-intercepts are the same as well. So in graph, there is only one line since the equations are exactly the same. There are infinite solutions. Any number will make the equations true or equal. And it's infinite because the lines go on forever. They go on for an infinite amount of time. Therefore, there are an infinite amount that they can share. Now, the only thing you need to do, and you can see this a lot with infinite solutions, is you got to make sure they're both in slope-intercept form. So y equals slope times x plus or minus your y-intercept. So this is in slope-intercept form, but this one isn't, okay? So we need to make sure we put it in slope-intercept form. So basically, my goal is to get y by itself. So I need to get rid of this -2x so that way that I have that y by itself. And we're going to use the same properties as we do solving equations. And we are solving an equation just for a variable instead of a number. So the inverse of a negative is to add. We're going to do that to both sides. So I'm left with y on the left because these cancel out. Now I cannot add 1 and 2x together. They're not like terms. So I'm just going to leave it as 2x and then bring down the positive 1. And now you're going to see these equations are exactly the same. So it might not have appeared that way with the first equation they gave us, but once we changed it to slope-intercept form, they end up being exactly the same. So I'm just going to need to plot one line. So I'm going to start at 1 on the y-axis, up 2 over 1, up 2 over 1. And once again, I only need one line since it's exactly the same. So just as a quick recap, we have one solution where they're going to intersect at one point, no solution where they will be parallel lines and share no common points, or we have infinite solutions where it is the exact same line and they're going to share all points. The only thing you need to be careful with is to make sure it's in true slope-intercept form before you graph and see that it is in fact infinite solutions. So you're going to continue to practice this today. If you have any questions, let me know, and I will see you all soon.